Hello, good afternoon. I think I'm just remembering now that somebody sent me some problems to do. I did not load them, so I'm just going to do the ones that I did load, and then I guess, I'll look at that. I'll look at that later. Maybe I'll post that or do that tomorrow. Sorry about that. I just remembered. So, here we are. Who's here? Did you have a chance to look at the mock final questions? I have that loaded as well. To solve some of those problems, maybe you can send me a list of them that you'd like me to do or something. I do not have the solutions for the multiple choice. I have the answers, but not the worked out solutions. So if there's any of those that you want me to work out, I can do that for you. But what I really wanted to do is focus on the homework exercises I asked you to prepare. And these were available in the Moodle platform. Great to see you all. So send your questions along, either email or put them in the chat, and I'll just get started. All right, so a man accused of committing a crime, I'm going to make this a bit bigger for my eyes, takes a polygraph lie detector test. The polygraph is essentially testing the hypothesis. The null hypothesis is the man is telling the truth. So we assume he's going to be telling the truth and compare that to the man lying. That's the alternative. So if we have evidence against him telling the truth, then we'll be able to say we have evidence that he's possibly lying. Suppose we use a 5% level of significance based on the man's response to the questions asked. The polygraph determines a p-value of 0.08. What do we conclude? So what do you do? What is a p-value of 0.08? So what do we do with that? We make a statement, the concluding statement. So you'll notice in the exercises that I post, and then in the mock exam and some of the review exercises, that you get, you just get part of the problem. Okay, so I'm not asking you here in the multiple choice question, I'm not asking you to do all the 5 steps. I'm just asking you here, in this case, to do the 5th step, analyze and make a conclusion, given the p-value. So with that value, we always, with the p-value test, we always write p-value less than or equal to alpha means reject. So we're going to compare the p-value always to the level of significance. Remember, we're saying, how strange is it that we got the value that we got? What was the chance of seeing the value that we did get? The chance of seeing it was computed to be 0.08 or 8%. All right, and you're told that you're going to compare that to 5%. So the chance of seeing was 8%, and that, as compared to 5%, is not so strange. All right, we're not going to say that that's strange. We're only going to say it's strange if it was less than 5%. So in other words, the chance of seeing what we saw was 8%. That sounds very rare. Well, then you have to say compared to what, because statistics is about averages and relative measures. We say compared to what? We're going to compare it against a level that we set. If the likelihood is less than 5% and we see it, that's our type 1 test error that we allow for. In this case, it wasn't, so we fail to reject H0. So we conclude with Remember, this is, you write this, and every test is always like this. It doesn't matter if it was a left-sided test or right-sided test. I didn't write all the details in here. You know, how do they determine that? Is that a left? Is that a less than or equal to? Not equal to? Greater than? I don't know. It's just, however, that established is irrelevant. It's always that I'm comparing the p-value chance of seeing the evidence that I saw versus 5% in this case, or the level of significance alpha in general. So we got 8%, so I could write it like this. 8% less than or equal to alpha of 5%. No, it's not true, so we conclude with fail to reject. So we fail to reject. What does that mean? So it means we didn't find evidence against the null hypothesis. So which is the best answer? There is insufficient evidence that the man is telling the truth. There is sufficient evidence that the man is telling the truth. Okay, so the statement of the null hypothesis that we're trying to find evidence against is that the man is telling the truth. So what we have found is actually sufficient evidence to reject that the man is telling the truth. In other words, sufficient evidence to say that the man is possibly lying. Okay, so it's not insufficient evidence that the man is lying. It's sufficient evidence that the man is lying. So I'm going to cross that one out. The probability that the man is lying is 0.33. The probability the man is telling the truth is 0.33. I'm not sure where those numbers are coming from. There's insufficient evidence. There's insufficient evidence that the man is telling the truth. Okay, so either we say there is sufficient evidence in support, or failing to reject, right? No, sorry, we fail to reject. I just said that wrong. So we fail to reject. So there is insufficient evidence to reject. In other words, there's insufficient evidence. I just said it right now, but I said it wrong before because I forgot that we're not rejecting. Okay, so there's insufficient evidence that the man is telling the truth. That's not right. There is sufficient evidence that the man is telling the truth. This is tricky, isn't it? There's insufficient evidence the man is lying. Which one did you guys say? None. Oh, you say C, A, B, C. A, B, C. Oh my goodness. I put these questions, I didn't review them. Okay, there's insufficient evidence. So what I want to say is, this is the statement, I'll write out my statement and then I'll compare them. I want to say there is insufficient evidence that the man is lying. So that would be C. The one that I crossed out because I forgot my result. Okay, so what I want to be able to say is we fail to reject the null, and then I write there is insufficient evidence so there's insufficient evidence to reject. Another way of saying that is there's insufficient evidence that the man is lying. Sorry, I didn't prepare to give you the answer, but that's the answer. So it's going to be actually C. So some of you got it. Very good. So my mistake was forgetting that we're not rejecting because I was looking over here. So we're not rejecting, we're failing to reject. So in fact, C is the right answer. So that's the way to do it. Solve the problem. Don't look at the alternatives until you write out the answer. Okay, so there's insufficient evidence to reject In other words, there's insufficient evidence that the man is lying because there's insufficient evidence in favor of the alternative. That's how that would work. So if I confused you, let me know. Let's do another one and see if I can make up for it. Okay, a statistician conducted a test of H0 with a mean, so this is a mean test, so I actually have the parameters in here, equals 10, and it's a right side test for the mean mu of some normal distribution variable x, normally distributed variable x. Based on the gathered data, the statistician calculated a sample mean of 12 and concluded that H0 could be rejected at the 5% level of significance. So this is important. So whatever happened with the numbers, you find out the conclusion, and we're assuming that that's correct conclusion. H0 could be rejected. So that means that, again, the statement, right? We're going to write out the statement, p-value less than or equal to alpha implies reject H0. So that's what essentially we've done. We found a p-value that was smaller than 5%. So here's some statements. Let's see which ones hold. So a test that was repeated, but at a 1% level. So if you reject at 5, in other words, if it's less than 5, is it necessarily less than 1? No, right? Because it's just less than 5. It's not necessarily less than 1. So it could have been 4%, for instance. That's not less than 1. So this is not true. A test, okay, so now I'm going to change. If it's 9, so I'm going to keep the level of significance the same, but I'm going to change the hypothesis to a different value. And what will happen with that? And then in the third, what I'm going to do is I'm going to go to the two-sided test. So let me give you a moment. I'm going to give you 5 minutes to try and answer this one, and even try the third one if you see it or you tried it. Anyway, I'll leave you 5 minutes to try and work this out. So which statements are true, okay? Maybe 3 minutes, because some of you have already looked at this. Some people have given me an answer. Okay, 3 minutes. Okay, what answers do you have? Put your answers in the chat. Put your answers in the chat so I know that some of you tried it and I can continue. Keep going. Okay, well, all right, so let me see if I can work this out for you, if it helps. So the first one was not correct because I said that if it's smaller than 5%, if the p-value is smaller than 5%, so it's in the rejection rate, in the tails, right? If the tail probability for the T statistic or the Z statistic is the test statistic, let's call it, is less than 5, is not necessarily less than 1, so that's wrong. I'm going to jump to the third one before I do the second one because it's kind of along the same thinking. So if I'm rejecting a one-sided test, so you're rejecting, I'm going to have trouble making these. So you're rejecting a one-sided test. So that means that when we do this, you end up as an outlier over here, somewhere over here, right? Where this is 5%. That's what's happened. So you ended up over here somewhere. Does that necessarily mean that if the test was changed to a two-sided test, you would still be in the reject region? So now let's draw it as a two-sided test. And when I make a two-sided test at 5%, I didn't change the level of significance. I'm going to make it bigger here so I can squeeze this in. So if I do a two-sided test, and I put it here, remembering now, I have to, for a two-sided test to be in the rejection, you split up the 2.5 probability, 2.5 and outliers, right? On each side makes 5 total. So the chance of being there, the question is, are you actually going to be here or here necessarily because you're smaller than 5% on the right? No, right? Just because you ended up as an outlier here within the 5% rejection region doesn't mean you're going to end up here. This is much smaller. I could have drawn it a little bit more further away, but the point is that that's only 2.5 and this is half, right? So 2.5 would be more strict and put you'd have to be this far away, so further away, much more different, much more unlikely. So no, so 3 is wrong. That's what I'm getting at. So what we're down to, we have to see, well, actually, process of elimination, the only answer can be the second one because there's none of these saying none of the above. But let me explain why the second one is correct. So let's cross this out. The second one is correct because, and the answer is B, because what you're doing by changing the hypothesized value, think now everything is about the t-statistic, right? Whether that t-stat puts you in the rejection region far away as an outlier, if assuming that the distribution was centered at 9 in this case. Here it was centered at 10. So what you're going to be doing to get the test statistic is going to change now with this second option. The test statistic is calculated as the x bar minus the hypothesized mean divided by the sigma over root n, the new standard deviation. So if I put 10 as my test statistic and I move it, as my hypothesized value, if it was 10 originally and now I make it 9, what happens to my statistic? Now I'm not saying if it's a z or a t because they don't give me enough information. Let me go back and make sure. They don't give me enough information to know if it's a z or t. Do they say normal? I have to go back. It does say normal. Okay, so this is a z, let's say. So this is a z, assuming they gave me sigma. If they didn't give me sigma, then it would be a t. So actually I don't even know. So this is just going to be called, I'll call this the test statistic. Test stat, remember it's a statistic if you calculate it from the data. So the test statistic is going to be calculated this way, but now this number is going to go from 10 to 9 and all the other values are going to stay the same. So from 10 down to 9 makes the test statistic go up. That's the most important thing. So if it goes up, if it increases, that means that you're going to be more likely to be in the rejection region, right? You're going to be further away, a further outlier. So if it's already an outlier at 5, and now you make it further an outlier at 5 by changing the hypothesized value. So if the hypothesized value goes down, in other words, you're going to be further, deeper into the rejection region, and so the test will be significant. You will reject the null hypothesis. So the answer is B. I hope that makes sense. You can review my statements and convince yourself about that. But even if you didn't know that, how to solve that, you should have known by 1 and 3 that those are incorrect just by what I've already shown you. But now you know this, so I expect you to understand this. So if you don't, let me know so I can explain it again. Review my video, slow down my voice, whatever you have to do. Draw some pictures like I have to convince yourself. Just recapping, if you put a smaller value in here, the test stat goes up and it pushes it further into the reject region. Okay, so you're going to be even further over here. So it's going to make it just as likely that you're going to reject if you're already rejecting at 5%. Okay? All right. In fact, what you found out is that it is anyway, I won't make any grand statements. Let's just do it like that, question by question. Okay, so then going down, next one, unless you have any questions. Should I let you try this? I'll give you 3 minutes because I see a lot of people watching and maybe you didn't have a chance. So try this, 5 minutes. Anyone figured this out? All right, let me set it up because I think it's worthwhile in this case. We set up starting with the null hypothesis, and let's see what we've got. So we have a sample of 30, so that's n, and then you're told about the sample mean and standard deviation of stopping distances for the 30 vehicles. So this is the mean, and this is the standard deviation. Now, what you have to do, remember the two questions you have to ask yourself. What kind of hypothesis test is this? Or what kind of inference is this? This is inference on the mean. And the next question is, do you know sigma? Do you know the population standard deviation? The way that this is written, you do not. Okay, this is saying, maybe it should have said sample mean and sample standard deviation, but that's how you're going to read it here. Sample mean and standard deviation. If you are at all in doubt, look at the options. All of them are between, so that means you're going to be using the t-table. All right, so this is an S, and this is S, and this is X bar. So you don't have the information on sigma. If you did have the information on sigma, you would use that and calculate a Z statistic, but we don't have that. So this is S. All right, so we would like to test whether the true mean stopping distance differs from 150. So our hypothesis is against the alternative. The null is, remember, always, we write mu here, always an equals there, and whatever number I put for the null, I put it in the alternative, and I have to decide what the sign is here. So the mean is the 150, the true mean, you see? True mean differs from 150, so that's the statement of the status quo, 150. And then whatever I put here, I put there. And then differs means not equal, so that's the test I'm going to conduct. It's very important that I set that up because remember the alternative hypothesis is what determines how I compute my p-value. Okay, so with the information given, you calculate, okay, I'm going to say what to do and I'm going to give you 2 minutes to do it, and then I want to see some answers, some, your choice in the chat. So what you've got to do is you've got to calculate the test statistic with the information given. Calculate the test statistic, and then because it's going to be a t-stat, go into your table, the t-distribution table, and compute the p-value, remembering what the p-value is. Draw it, draw the curve, and remember in this case, because it's two-sided, you're going to look on both tails. Okay, so I'm going to give you 2 minutes to wrap that up, and I'll come back. I want to see some options or some choices of yours in the chat, and then I'll come back and solve it. So work at that. All right, I'm back. How'd you do? I only see Cataline wrote what she got, and she is right. Good for her. How did she get that? Let's see. So I asked her to compute the test statistic. The test statistic is computed. I'm going to use the formulas in the 6th row, right? Because I don't know sigma, I'm going to use S. So the T-stat for that is going to be the realized value, the observed evidence. We're going to standardize the evidence, which is 162 minus 150 divided by S, which is 35, divided by square root of 30. So you gotta put all that together and get your T value, your T-stat. That's your statistic, that's your value that you need to assess. And I get 1.8779 as indicated by Jane, 1.8779. So 1.8779, what do I do with that now? Now I take that with a degrees of freedom of 29 and I look in my table to see if it's there. So what I'm doing is I'm checking. What I need to do is I need to check on the T table with 9 degrees of freedom. I'm going to plot 1.8779 and I'm going to plot negative 1.8779 and I'm going to find out what is the chance of being either bigger than that or smaller than the negative of that. So the chance of being so far away in either direction is what I'm going to assess. So going to the T distribution, I'm not going to put it up because it's a lot of clicking and opening. So I'm just going to look at my T9 and I'm going to look for that number 1.8779. And I don't see it exactly like that, but I do see that it's between 2.5%. So remember that the T table gives you the right tail. It turns out that this is between, remember, between 2.5% and 5%. So it's between those two, but I have it on both sides, right? So I have it on both sides that it's between 2.5% and 5%. So that's also here. Right? So then I have to add those together. So when I add those together or I multiply 1 by 2, I'm going to get between 5 and 10%. So that's actually my p-value. So that was my test statistic that I plotted initially. I calculated and I plotted it. And then I had to figure out the associated p-value because I'm not so familiar with the T distribution. It all depends on the degrees of freedom, and I can't tell you outright. And other people reading it might not be familiar with what it means to be 1.87 standard deviations away. So you convert it into a probability of being there. And everybody understands if that's smaller than 5 because you can just compare it. Okay, so the p-value is actually, I'm going to have to write it somewhere. I'll just do it down here. So the p-value of that is actually equal to between 5%, because I'm doubling it, and 10%. And so when we conduct the p-value, the assessment of the p-value, we write, like we always do, p-value less than or equal to alpha means reject, but because it's not, we're going to fail to reject. In this case, we got so you write between just my short form for between 5% and 10% is not smaller than an alpha that's always set at 5. Did they set it at 5 in this problem? I have to go back and check now. Is it at 5%? Hope it helps when I go back and forth. So what was the alpha? Oh, it was 1%. Sorry, it was not 5%. It was set at 1%. That's totally, can't erase it by itself. Okay, let's just write it again. So between 5% and 10% is not smaller than 1%, so I fail to reject. I don't reject, the test is not significant, and that's the option I'm looking for. So like I said, solve the problem completely and then go to your alternatives. Don't look at the alternatives, because sometimes you might be misled to think that you've got the answer. You haven't even finished solving the problem yet. Right? So make sure you've completely solved the problem and then go into your answers, and you'll see that that is precisely option D. Okay? So Catalin got it right. So if you need help, ask Catalin, she understands. Right, so I usually, Delia, I just draw it and solve it. It looks like you use software or something. So that's great, you got a precise value of 7.02%. Excellent, Delia. So yes, you could use software, you could do, there's online computers or calculators to help you, or you can use Excel to get the value exactly. Okay, the table's just enough for you, but if the table bothers you, you want more precision, whatever you like. Yes, Delia, excellent, 7%. That probably makes sense. That makes sense because it's between 5 and 10. Okay, so I solved all the problems of the homework. That took the whole class practically. Well, what I'll do, I'll let you go early. What I'm going to do is prepare the questions that someone sent me for tomorrow, and please send me any questions you have about the mock. So I'll solve the mock problems you have. Would you like more homework, or do you have enough? There's also the review exercises that are up there for the final. If you'd like more homework, just write please more homework in the chat, and I will put some more questions up just like I did today or yesterday not yesterday, but on Friday for today's class. So let me know if you want more homework exercises, and I will post them. Okay? So I'll just give it a moment to see if you write me, because there is a minute delay. Otherwise, I'm going to wish you well. Keep in touch and keep progressing. Keep on swimming. And we will talk tomorrow. Bye.